Hello everyone and welcome to the next lesson about the diode. In the previous lessons we already discussed about some basic principles of the diode and how to analyze the diode inside a circuit using three different models. I also provide you the manuals how to check the diode if it is functional or not. So in these lessons we're gonna talk about some applications using the diode. Okay, so the first one I would like to present you is this applications. Actually this is a kind of limit switch for a motor when we have a movement from this side to this side. So this slide is already presented in the first lesson, so I just remind you for the principle of the circuit. So when you provide the voltage to make the motor move to these directions, okay, so the current will be in this direction. So normally this circuit is normal closed state, so means that this is the connection from this pin to this one. So you have the current and the motor is moved. However, when the motor reach the limit, the switch is open, okay, so the current will pass through the diode. However, with this connection, the diode is in reverse bias state, so means that there is no current passing through the diode and the motor is stopped. However, if you provide a voltage to make the movement in this side, the current will pass through the diode and the motor will move to the right side of the picture. Okay, so this is a very popular application using the diode to protect the mechanics of your system. However, we have other types of the diode, like very popular to us is the LED, the light emitting diode. And the second one I would like to present to you is a Zener diode. Okay, so different to the normal diode, the use of the Zener diode is in a reverse bias state instead of the forward bias state. And the last one is some array of diodes and it put inside an integrated circuit. And we call it is a kind of diode array. Okay. So for the first devices acting like a diode, it is a light emitting diode. Okay, when you provide the drive voltage or put the device in forward bias state, you have some light. This is the most population application using the LED. However, there is another type of application using the LED is you provide a reverse voltage, meaning that you provide the positive here and the negative here, and in this case the LED becomes a kind of light sensor device. Okay, so the most application using this technique is some very big screen using the LED, and you use the laser beam to interact with the LED. So in this case there is a period that the LED is in a reverse voltage, so in this case it acts like a light sensor device. The second diode I would like to present to you is a kind of Zener diode. However, we don't use the Zener diode like a normal diode frequently. The most application using the Zener diode is to put it in a reverse voltage, like here. So normally the right voltage is positive here, but we put it in a reverse voltage, which is the positive is in this pin and the negative is in this pin. Okay, with these connections, when the input voltage is higher than the threshold, the output is almost stabilized. The output voltage is almost constant. So with this characteristic, the Zener diode is normally used to stabilize the output voltage before you power another circuit. So the most popular connection is like here. Okay, you connect the Zener diode in a reverse voltage, and this is the picture of a Zener diode. Okay, and This is a kind of integrated circuit using diode. So you have multiple diodes inside a package, and we call this is an IC, and this device is a kind of diode array. Okay. Yeah, this is the most application using a diode uh, you use to protect your circuit. So with this connection, you cannot provide a wrong connection to your circuit. However, you're gonna drop around 0.7 with these connections. If you want to avoid this behavior, you can choose a better diode, which is the Schottky diode, and you have a very low drop down voltage. However, for some devices, you can use the diode to provide the right voltage. Also, you also protect the circuit, but you can provide a very right voltage to your device, like this module. Actually, this one is used to send a message or to make a call, and the price is very low, just around $2. However, the right voltage is for the 3 volt, it is not 5 volt, so please remember. So if you are lazy, you use 5 volt power for this device. It is very hot and the lifetime is reduced very quick. So in this case, you can use a diode not only to protect your device but also to provide a right voltage to your device. And the next one, I would like that you can design a circuit and make a power supply for your future system. It is a kind of converter from AC to DC, and we use this device. It is a kind of diode bridge. Okay, and the name of this circuit is the full wave rectifier circuit. Yeah, the principle is very simple, so you can try to investigate a little bit by follow the animation in this slide. Okay, so the full connection of this circuit is proposed here. Okay, you have these devices and it is an integrated circuit, and there are 4 different diodes inside. So actually you use a kind of AC input. You have a transformer to reduce the voltage from 2000 to around 5.9 volt for instance, but at this point it is still AC current. You pass through a diode to have an DC at the output, and we have several capacitors to stabilize the output, and finally we use an IC which is 7805 to make the output is 5 volt. Okay, so this is the full connection of the circuit, and I hope that you can draw a schematic of this one, simulate the circuit, make the board, and put the components in your board, and you have your own power supply. So in some cases, we use the diode like a logic gate. Okay, so the reason we use the diode for the logic gate is because normally we only need one gate in the circuit. So in this case, if you use an IC which is normally has 4 gates, you can increase the size of your circuit and also increase the footprint of your circuit. So in this case, you can use 2 diodes, it is better. So like here we have like the OR gate. Okay, so when you have 5 volt at the input, the output will be around 4.7 volt. So it is also the logic 1. Okay, if you have 5 volt here, the output will be 0.7 4.7, and you have 1. But in this case, when you have 1 here, when you have logic 1 here, which means this is around 5 volt, and we don't have the different voltage, so we don't have the circuit, and we don't have the current, so means the output will equal to 5 volt, so it means it is 1. If you have 5 here, 5 here, the output will be 5 volt. Okay, because we don't have any current. But if you have 0 volt here, so the voltage here will be 0.7. So please remember, we have a drop-down voltage through the diode, and the output will be 0.7 volt, and it is still equivalent to logic 0. Okay, just one input is 0, the output